Hi, I'm Jacob.
Hi, I'm Vikram.
Hi, I'm Bridget.
And we're ML4VA.
Sometimes. So we want to do our part to help the community. For this project, we decided to analyze Charlottesville crime statistics.
We sourced our data from data.virginia.gov. The data contains over 32,800 observations of crimes in Charlottesville with features such as type of crime, date and time, and the location the crime was committed.
We engineered an additional feature to categorize the crimes by their severity.
We classified crimes such as shootings, robbery, and other harmful or felony crimes as severe.
And then we classified more minor crimes such as traffic stops as non-severe.
Our goals were to better understand the geographical distribution of crimes across Charlottesville and which areas were more dangerous, as well as to predict the severity of a crime based off its characteristics.
After cleaning our data and running it through a data processing pipeline, we were able to start our analysis.
First, we used k-means clustering to visualize and explore the geographic distribution of crimes across the city. We graphed the inertia of models with varying numbers of clusters to determine the optimal value for k was 4.
Cluster 0 covers downtown Charlottesville, Belmont, and Pantops. Cluster 1 covers northern Charlottesville. Cluster 2 covers most of the central Charlottesville, overlapping with the other clusters. And lastly, Cluster 3 covers the University and Fry Spring.
The proportion of crimes occurring at night were low for cluster 0, 1, and 3, but roughly 50% for cluster 2. And the proportions of severe crime were similar across all clusters in the low 60s. The lowest proportion was in cluster 0 with 56% severe crimes.
The cluster with the highest proportion of severe crimes was actually cluster 3, which contained the university. However, the majority of severe crimes in this cluster occurred away from UVA and towards downtown Charlottesville.
Next, we built a random forest classifier to see whether we could predict the severity of a crime based on its location and time of day.
After tweaking our model, we were able to get a relatively decent F1 score of 0.67, with the precision being 0.65 and recall of 0.70. While this was not as great as we would like, we still think it's interesting that we can predict crime severity without including any information on the crime's incident category or crime committed. Also, a higher recall is better than a higher precision in our case, as we would rather misidentify non-severe crimes as severe than misidentify severe crimes as non-severe.
We also graphed the median decrease in impurity for each feature in our model to visualize feature importance. Here, we can see that the time of day the crime was committed was more significant to predicting its severity than the location it was committed at.
If we include incident category as a category in our model, we were able to reach an F1 score of 0.936 with a precision of 0.93 and recall of 0.93, which is much better than before. However, we don't think this would be very useful in the field as incident category is highly correlated to what the actual crime was. For example, a hit and run crime would have been an incident category of traffic.
While our model was very effective if we include this category, we think that a slightly less effective model that uses much more basic information will be more useful in practice.
If we were to actually implement our models in the real world, we would likely opt for a hybrid approach, predicting crime severity based off of all known information in real time.
Just for fun, we also try to do a nonlinear Gaussian RBF to see if we could draw a more clear geographical border around where severe crimes tend to happen. However, because of factors like limited data and other factors influencing crime severity, our SVM performed pretty poorly.
Hey, we tried.
Overall, we are pretty proud of our results.
We managed to visualize Charlottesville crime data by grouping incidents by location as well as time committed. And using this insight, we were able to tune a few models to try to predict crime severity based on limited information.
Through this, we learned that there is a lot of factors that correlate with crime severity. We think that if we were actually to implement this, making some sort of real-time tool, we would train much more complex models with constantly changing parameters.
Thank you for watching our ML4VA project.
ML4VA!